Now, do you remember a while back when we looked at simplifying radical expressions where the radicand was a fraction? Well, we're now going to go back and revisit those kinds of problems, but this time we have to keep in mind that final guideline that we talked about a minute ago, which is that we don't want to leave a radical in the denominator of a fraction. So for our first example, we have the square root of 10/7. Now, in general, when you have a fractional radicand, if you can reduce the fraction inside first, that's often helpful to do. In this case, however, we're not able to do that, so what we'll do is rewrite using the quotient property as the square root of 10 divided by the square root of 7. And now we need to think about what we would multiply by to rationalize the denominator. And I think you're all smart enough to know that that would have to be then the square root of 7 divided by the square root of 7. And so we'll have then in the numerator the square root of 70, and the denominator is the square root of 49. So we have the square root of 70 divided by 7. Now you want to look at that numerator to see if there's any way we can pull out a perfect square factor. And I think you'll agree 70 does not have a perfect square factor, so we can't simplify the numerator. So our final answer then is the square root of 70 divided by 7. And our second example, again, let's look to see if we can reduce that fraction inside, which we're not able to do. So we'll rewrite this then as the square root of 200 x to the 6th divided by the square root of y to the 5th. Now what we'll do is to try to simplify each radical first before we go any further. So we'll be looking in the numerator for factors that are perfect squares, and I think you'll agree that the 200 can be broken down into 100 times 2, and the x to the 6 is already a perfect square. And in the denominator, we can rewrite that as the square root of y to the 4th, then times y. So going back now to the numerator, the perfect square factors that will come out, if you will, of the radical will be the 100 and to the x to the 6th. So we'll have then on the outside of the radical 10 x to the 3rd power. Then we're left inside then with the square root of 2. And in the denominator, the perfect square factor that we have is y to the 4th. That will come out of the radical as y squared, and that will be multiplied by the square root of y. Now, since we have a radical left in the denominator, we need to rationalize the denominator. So we'll multiply numerator and denominator here by the square root of y. So in the numerator we will have 10x cubed times the square root of 2y. Denominator y squared times the square root of y squared. So we have 10x to the 3rd times the square root of 2y all over y squared times y. And so our final answer then will be 10x to the 3rd times the square root of 2y divided by y to the 3rd. And I think you'll agree that we're not able to reduce that fraction any further, and the square root of 2y is in simple form, so that will be our final answer.